Hello students, welcome back to Physics Class. I hope you're all doing well. So in today's class, let us discuss some interesting topic, that is impulse and impulsive force. So let us try to understand the impulsive force as well as impulse in detail. Children, what is meant by impulsive force? Impulsive force is the large force that is acting for small interval of time. I repeat, a large amount of force acting for small interval of time is called as impulsive force, whereas this force produces a finite change in momentum. This force that produces the finite change in momentum, and this is equals to the product of force and time. Okay, so that means the change in momentum produced by the given force, the change in momentum produced by the given force, and which is equals to the product of this force and time is called as impulse of the given force. Impulse. So impulse of a force is defined as the change in momentum produced by the given force, and it is equals to the product of the force and time. So every time you need to understand that I am focusing more, I am stressing on the term force. Okay, so what force am I stressing on? Impulsive force. This impulsive force is nothing but a large amount of force acting for small amount of time, and this force will produces a finite change in momentum which is equals to the product of this impulsive force and the time. So children, from Newton's second law we have observed that from Newton's second law, we observed that what we know from Newton's second law means F is equals to ma. F is equals to ma. Force is a vector quantity and acceleration is also vector quantity. So to represent vector quantity, let me indicate with bar overhead. So F bar can be written as m into the formula. Acceleration can be defined as the rate of change of velocity, that is change in velocity upon time. So acceleration can be written as v minus u by t. Since velocity is a vector quantity, I can represent with v bar minus u bar by t. So children, so after further proceeding, it can be written as this t, if you bring it the other way, then this will become f bar into t is equals to m times of v bar minus m times of u bar. Okay. So this is all about the concept of impulse and impulsive force. A large force acting for small interval of time is called as impulsive force, and the impulse of this force is defined as the change in momentum produced by this force, which is equals to the product of force and time. Change in momentum which is equals to the product of force in time. That means product of force and time is nothing but F into T, which is also equals to mv minus mu. Now to discuss with the SI units of this impulse or impulsive force. Impulse or impulsive force. First of all, let us try to understand the SI units of this impulse. Impulse is nothing but the product of force and time. Impulse is nothing but the product of force and time. Okay, so product of force and time means SI units for force is nothing but Newton second. Force is measured in Newton, time is measured in second. So the SI unit of impulse is F into T is nothing but Newton second, or it can also be written as change in momentum. It's nothing but whether it is a change or whatever it is, the physical quantity here is all about momentum. Momentum is nothing but your product of mass and velocity. So for mass we measure in SI system in kgs, whereas velocity we measure in meter per second. Hence SI units of this impulse is either Newton second or kg meter per second. Now to discuss with the CGS unit of impulse. So here instead of Newton we represent the same with dyne, and here as usual second. Okay, SI unit, CGS unit of force is dyne, whereas time is always measured in seconds. So dyne second is the CGS unit of impulse or the product of mass and velocity. Okay, for mass we measure in CGS system as grams and velocity as centimeter per second. Hence SI unit is either Newton second or kg meter per second, whereas CGS unit is dyne second or gram centimeter per second. Okay children, now let us try to understand the concept in detail with real life examples. Children, have you ever observed a nail being hit by a hammer? So during this process, hammer applies a large force on the nail but for a small interval of time. Okay, so this large force is nothing but your impulsive force, and the process, this force acting for small interval of time on the nail, this product of the force and time is nothing but your impulse. So force acting by a hammer on the nail is the best example for impulse. Similarly, a cricket ball hit by a bat, if you observe, impulsive force is being acting by applied by the bat on the ball for a small interval of time. So the product of the impulsive force acted by the bat for a small interval of time on ball is again an example of impulse. So two examples I have discussed: force acting by a hammer on the nail, force applied by the cricket bat on a ball. Both are examples of impulse. Children, you would have observed that a person who falls from certain height on a cemented floor gets hurt or gets injured easily. Whereas if the same person falls on a heap of sand from the same height, then he won't get hurt easily. The reason behind this is the cemented floor does not yield properly. Meaning of yielding is nothing but the cemented floor does not get compressed properly. So because of this, large amount of force is applied by the cemented floor on the person for a small interval of time. Immediately the person will get hurt. Hence he gets injured. Okay, here it is, the impulse force is large because it is acting for small amount of time, the force applied on him is larger and hence gets injured. Whereas if the same person falls on the heap of sand, there is a possibility of the sand to get yielded up, get compressed slower. That means the time lapse is being increased whenever this person is falling on the heap of sand. Whenever the time is increased, the impulsive force acting on him is reduced. The reason why he won't get hurt easily. Okay children, so here as the time gap is increased on the heap of sand, the impulse force acting on him is lesser because it is a product of force and time. Time increases, force reduced. On cemented floor, what happens means less amount of time, so large force is being increased. So the product of force and time always remains constant. The product of force and time always remains constant. So whenever time gap increases, the force will be reduced. Whenever there is a less amount of time is acting, large amount of force is being applied. So this thing you need to understand. This is the main reason why whenever if you observe the China ware means pingani you say, no? So the chinaware or a glassware, if you observe, so whenever you get it from you purchase it, then the shopkeepers will be sending you. So whenever you open that cardboard sheets and all, they are being wrapped on in a piece of paper, or some hay is being kept inside, some grass like structure, hay is being kept inside, so whenever it is being shaken during the transport and all, so because of the shake, that force might be acting on this glassware or the chinaware. And to reduce the force, impulsive force acting on this chinaware or glassware, so these people will be wrapping them in some newspaper, some paper like structure, or some husk like structure, so that the time gap of the impulsive force is being increased. Whenever the time limit is increased, the force acting on it, the impulsive force acting on them, will be reduced. As a result, the materials will be brought safely, they won't break up easily. Okay, children. So not only this, children, you would have observed that so whenever you go by a vehicle, whether it is a car, bus, truck, motorbike, whatever it is, okay, children, so you would have observed that the back wheel of this motor vehicles or whatever it is, there are some, like the wheel is something like this, spikes, okay. You would have observed that it is been attached something like this, some spring like structure is there, on which something like this, it is been attached to the back part. So this is nothing but shock absorbers, spring like structure. So whenever it comes onto the speed breaker and all, so what happens means the force exerted by this road on the vehicle will be impulsive force, whatever it is. So in order to carry the force to the person sitting on them, this time gap is being increased because of the shock absorbers. As and when the time gap is increased, the force, impulsive force acting on the person will be get reduced. So the reason why shock absorbers are being used. So by increasing the time gap, we can reduce the impulsive force acting on the persons. Hence, they can be taken safely. Okay, children. Not only this, children, if you would have observed the bogies of the train and all, between two bogies, there will be some buffer like structures, it is being attached, something like this. Okay. So two engine bogies, if you observe, these two are connected with, so this is one engine bogie and this is another bogie. All the trains are being, all the bogies are being attached like this with the help of some buffers. Okay, between one bogie and one in goods and all, you can observe it carefully. Not only that, even the passenger train and the express train also, you can observe that buffers. So every bogie is being connected like some spring like structure, buffers. One will go inside like this. Okay, so these bogies are being connected with the buffers, so that because of the same reason, to increase the time gap and to reduce the impulsive force. Children, then if you would have observed that athletes, whoever are there during the running race and all, so these people will travel for some larger distance. Okay, whenever they are in the running race, after finishing up the race also, they will run for few more distance. Okay, what is the reason behind that? In order to reduce the force acting on them, they will be increasing the time gap. Okay, so even after the finishing of the race also, these people will run to some distance ahead to reduce the force acting on them. Okay, by increasing the time of impulse. So this is also an example where the impulse is taken. So children, if you observe that whenever you hit a cricket ball and a tennis ball, both are thrown towards you, you feel easier to hold, to catch the tennis ball, but you feel little difficult to catch the cricket ball. Why? Because the mass of the cricket ball is more when compared to the mass of the tennis ball. As I said, this impulse is nothing but force into time, but also which is equals to product of mass and change in simply change in velocity or simply change in momentum. So wherever the mass is larger, wherever, here I can say like this, M into V bar minus U. So whenever force into time is nothing but product of mass and change in velocity. So whenever mass is been more, what happens? We have the impulsive force will be more. So whenever mass is less, the impulse will be lesser, because it is also equals to change in momentum. So based on this, children, and one more example, say if you travel like vehicles, okay, whenever you observe a collision between accident, okay, collision between two vehicles, then the vehicles will get damaged so easily because of large amount of force acting for small amount of time. The vehicles can easily get damaged, okay, because of the change in momentum. Change in momentum, this condition, the change in momentum produced by the given force, the vehicle gets damaged easily. This is also due to the impulsive force, children. So based on this concept, whatever we have discussed, let us try to solve few numericals, children. So what is impulsive force? The large force acting for small amount of time, and this impulse of the force is nothing but the change in momentum produced for small amount for a given time, which is equals to the product of force and time. From Newton's second law, we have F equals to ma, or A can be written as V minus U by T. This T, if you bring here, Ft is equals to mv minus mu. Ft is nothing but impulse, okay, or mv minus mu is also said to be your impulse. Either Ft or mv minus mu is nothing but your impulse. So few examples also we have discussed. What are the examples, children? The first example was a hammer, any nail hit by a hammer, a cricket ball hit by a cricket bat. Next, chinaware or glassware wrapped in some hay-like structure or some paper pieces, and also buffers used in between the engine, bogies, shock absorbers in the vehicles, any vehicles, car, bike, scooter, I mean what are the truck, bus, anything, shock absorbers to reduce the impulsive forces. And it is easier to catch a tennis ball when compared to the cricket ball because of the lesser mass in tennis ball and larger mass in cricket ball. This formula, m into v minus u, okay, ft, where mass is larger means then you have lesser impulse force will be there, children. So based on these examples, let us try to solve the numericals. So first numerical, children, force of 15 Newton acts on a body for 10 seconds. How much force was given? Force was given as 50 newtons and time was given as 10 seconds. You are asked to find the change in momentum. Children, we know that the change in momentum is nothing but the product of force and time. Change in momentum is nothing but product of force and time. So this part is nothing but your change in momentum, where change in momentum is equals to force. How much force they have given you? 50 newtons. Force is given as 50 newton into how much time they gave it as, children? 10 seconds into 10. So change in momentum is equals to 50 into 10. That is 500. So change in momentum equals to 500. What are the units of force, children? Force is measured in Newton, 50 Newton, time is measured in seconds. Hence the change in momentum indicated with the letter change in momentum is equals to 500 Newton second. Okay, children? So change in momentum is product of force and time. Force is given as 50 Newton, time is given as 10 seconds, 50 into 10 is 500. So change in momentum is 500 Newton second. Children, what is the unit of kg meter per second? Is the unit of what? Kg is nothing but mass, meter per second is the unit of velocity. So momentum or change in velocity. So this is nothing but the product of force and time. So what is this product of force and time, or m into v minus c? It is nothing but your impulse. Okay. So what is which answer? Fourth option. Kg meter per second is the unit of impulse. Force it is newtons or kg meter per second square. Velocity meter per second. Acceleration meter per second square. Whereas impulse is kg meter per second. Moving ahead, change in momentum is same as change in momentum. Just now we have discussed here, change F into T is nothing but your change in momentum. Either change in momentum or the product of force and time, both are nothing but your impulse. So, change in momentum is same as what ma? Answer is impulse. Change in momentum is nothing but impulse. Moving ahead, what will be the impulse on a body at rest when acted by a force of 4 Newton for 2 seconds? What you are asked to find out? Impulse. So, impulse is nothing but the product of force and time. Here nowhere no knowledge regarding the momentum or change in momentum is given. So, simply force and Newton. What is the value of force given, children? 4 Newton into time is given for 2 seconds. So, 4 into 2 is 8. Answer, force is measured in Newton, time is measured in second. Hence, the value of impulse is equals to 8 Newton second. What is the value? 8 Newton second. So, answer is third option. Next question, children. A 250 gram ball moving at 20 meter per second, it stopped by a player in 0.01 second. What impulse did the ball exert to player's hand? So, like this, if it is even given complicated, so let us try to write the given data first of all. Okay. So, what is given data? Mass is given as 250 grams, but options are given in Newton second SI system. So, let us convert in SI system. 1 kg is 1000 grams. So, 1 gram is 1 by 1000 kg. So, 250 grams is 250 by 1000 kg. So, I converted this in SI system. What else is giving? The ball moving at a speed of how much was given? Speed is given as, velocity is given as how much? 20 meter per second. Speed or velocity is given as 20 meter per second. Finally, it is being stopped. Okay. Okay. And player time is given as how much, children? 0.01 seconds. So, mass is given, velocity is given, time is also given. What impulse did the ball exert on the player's hand? Children, we know that impulse is equals to force into time. So, nowhere force is given, time is given. Though time is given, force is not given. First of all, let us try to find out force. What is the formula for force, children? Mass into acceleration. How much is the mass, children? 250 by 1000. Into acceleration. Acceleration is nothing but the rate of change of velocity. So, velocity upon time. So, I can simply write it as mass into change in velocity by time. So, 20 meter per second, the other velocity was 0 because it was being stopped. What is the change? It's nothing but 20 minus 0 is 20 itself. So, mv by t, where m is given as 250 by 1000 into velocity was given as 20 and time was given as how much? 0.01. Okay, children. So, after further simplification, we have the value of F as 250 into 20. So, 250 into 20, let me cancel this value, children. 1 0 I'll get cancelled. 250 into 2 is 500. Okay, so 500 upon how much is that? 100 into 0.01 is 1. So, the value of force is 500 newtons. So, it is how much? 500 Newton. But what you require is you need to find out the impulse. I hope the concept is clear, children. Formula for impulse is nothing but impulse is equals to force into time. Impulse is nothing but force into time. So, time is already given but force is not given. So, initially what I did was I tried to find out the value of force. Formula for force from Newton second law, F equals to ma. Acceleration nothing but velocity by time. So, m into v by t. What is the value of m given? 250 grams. In kgs it is written as 250 by 1000 kg. into velocity by time. How much velocity? 20 meter per second. How much time? 0.01 second. Simplify this. 0 gets cancelled. 250 into 2 is 500. Denominator 100 into 0.01, it is equals to 1. So 500 by 1, answer is 500 Newton. Hence the value of impulse is equals to force now is found to be 500 and time was given to be 0.01. 2 decimals after, okay, here 2 zeros. So after multiplying, how much you are getting, children? Which is equals to 5 Newton second. Newton second is the unit of impulse. Where is 5 Newton second is second option. Okay children, force into time. Force was 500, time was 0.01. Okay, moving ahead. Sixth question. A body of mass 100 kg moving straight line with a velocity of 30 meter per second. So let us try to write down the given data. Mass is given to be 100 kg. Velocity was given as 30 meter per second, moves in opposite direction with a velocity of 20 meter per second. Okay, so two velocities are being given. One is 30 meter per second, the other meter is 20 meter per second. Okay, not like this. After hitting a wall. So let me explain it clearly. A wall is there, children. Wall, a body of mass is there. This mass having 100 kg. Okay, initially some velocity it is moving. What velocity it is moving? 30 meter per second. Once the mass, the body, once the body hits the wall, again what happens means it's again, after hitting the wall, it again moves back in the opposite direction. This is in the forward direction, this is in the backward direction. After hitting, it again travels in the opposite direction. With what velocity they gave it as? 20 meter per second. So initial velocity is 30 and final velocity is 20. What is the magnitude of impulse? Children, we know the formula for impulse as either force into time or which is also equals to change in momentum. Change in momentum is nothing but V minus U. We have no knowledge regarding the force or some time, but mass is given, the velocity, change in velocity are also given. So let us try to apply the same formula. So based on that, we can find the value of impulse as mass. What is the value of mass given, children, here? 100 kg into velocity. So final velocity, how much, children? It is 20 meter per second. Children, if you take forward direction as positive, then backward direction must be negative. Direction is opposite. If this is positive direction, other must be negative direction. So here instead of V, how much I iterate? Magnitude is 20 meter per second, direction is opposite. So for the representation of direction, I represent minus. So instead of 20, because it is moving in opposite direction, I need to represent as minus 20. This minus as it is. U means how much they gave? 30 meter per second. Positive x-axis, I took it as positive value, and negative x-axis, I took it as negative. So this is my plus 30 meter per second, and opposite direction minus 20 meter per second. This is the value of U, and here the value of V. So instead of V, I replaced minus 20, this minus as it is, and instead of U, what is the value of U, children? Plus 30 meter per second. Hence the value of impulse is found to be 100 into minus 20 minus 30 is nothing but minus 50. So children, 100 into 50 or minus 50, how much is that? 5,000. How much is that? 5,000. Minus is also been kept, Newton second. Okay, so what is the final answer? Minus 5,000 Newton second. So minus indicates the direction. That means it moves in the backward direction. The impulse acts in the negative direction. How much impulse? The magnitude of impulse is 5,000 Newton second. Here the magnitude of impulse only they were asking. What is the magnitude of the impulse? 5,000. direction is opposite. Okay, so answer is your second option, 5000 Newton second in the backward direction. But as they were asking only magnitude, no need to write this symbol. Okay children. So this might be the last question children. I hope you understood the concept regarding what is impulse, what is impulsive force, how long it is acting, its formula, units and applications. Okay. So let us conclude our topic from here and meet you in the next class. Thank you children. Have a nice time.